Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is my video lecture over section 3.7, which goes over arguments and checking for the validity of arguments. So an argument will have two main parts to it: premises or premise, and the conclusion. So an argument will determine to be valid if the conclusion is true whenever the premise are assumed to be true. So we'll always, for any argument, we'll always assume that the premise are true, and if that necessarily means that the conclusion also has to be true, then the argument will be valid. But if there's in any other situation, if we can't necessarily if we can't necessarily determine that the conclusion is true based on the premises being true, the argument will be invalid. So I'll state it one more time. We'll always assume the premise are true. If that necessarily determines that the conclusion is true, then the argument is valid. But if we have various premises, and we cannot determine necessarily that the conclusion is true, then the argument is invalid. So the book likes to show these standard forms of valid arguments and invalid arguments that are pretty typical ones that we see. So these are all in symbolic nature, and I just want to be clear about what we're seeing here. So the lines above the horizontal line here are the premise or the premises, all right, and the line below the horizontal line is the conclusion. This 3-dot thing here means therefore, and so here are the premise and here is the conclusion. Here are the premise, here's the conclusion. So basically the main forms of premise that we're going to deal with are if P then Q statements. You see that here in these 4 boxes. And then we'll give you some form of P or Q or not P or something like that. And then we'll make a certain conclusion. The other basic premise that we're going to be dealing with is P or Q. All right, so keep in mind that when I talk about these ones, when we assume that P or Q is true, that means that at least one of these statements is true. It could be just P being true or just Q being true, or both could be true. That's a truth value, something we went over in a previous section. Now the transitive reasoning and misuse of transitive reasoning is really just double direct reasoning. They say if P then Q, then if Q then R. Well, then if you have P, then you have R, and that's just a transitive meaning too. It's a double direct reasoning. So let me kind of go over these, and I'm going to use an example that I think is pretty simple to think about. So let P be the statement live in Denver, and Q be the statement live in Colorado. So I'm going to use that for these 4 here. So we know. So if we assume that it's true that if somebody lives in Denver, then they live in Colorado, which is true, and we know that somebody lives in Denver, then we can conclude that they live in Colorado necessarily. So that's valid direct reasoning, and that's pretty basic. That just basically says if you have P, then you get Q. P leads to Q. Well, of course it does. The contrapositive reasoning is if you live in Denver, then you live in Colorado. We know somebody that doesn't live in Colorado, therefore we can conclude that they don't live in Denver. And that makes sense, because if they don't live in Colorado, they definitely can't live in Denver. All right, and we talked about this in 3.5, how the conditional and the contrapositive have the same logical equivalency, truth equivalency. So that's why these logical arguments will always be valid. As far as if-then statements, there's some invalid forms that are pretty common. One is called the fallacy of the converse. So I'll use this example. If P, then Q, or sorry, if you live in Denver, then you live in Colorado. That's a premise we assume to be true. Somebody lives in Colorado, therefore they live in Denver. We know that's false because these premise, even if we assume if you live in Denver, then you live in Colorado, and somebody lives in Colorado, I can't necessarily conclude that they live in Denver, because they could live in Fort Collins or Aspen or Vail or Grand Junction. So this is a fallacy. It's an invalid argument. Doesn't work. The fallacy of the inverse is, so let me read the statement. If you live in Denver, then you live in Colorado. Somebody doesn't live in Denver, therefore they don't live in Colorado. And we know that that's false because even if you assume that if somebody lives in Denver, they live in Colorado, and you assume that somebody doesn't live in Denver, you can't necessarily conclude that they don't live in Colorado. Somebody could not live in Denver but live in Fort Collins, and that would nullify this, and because this says that they don't live in Colorado. Well, somebody who doesn't live in Denver could live in Fort Collins and also live in Colorado. So these are fallacies. All right, then disjunctive reasoning, the way this works is that if we assume that P or Q is true, all right, so if basically we know that P or Q is true, or both of them is true, and then we assume that not P is true, that means that Q must be true. So another way of thinking about it is if we know for sure that P or Q happened, but P did not happen, we're assuming that, then Q has to have happened to make this premise true. So, and this is the same thing. If P or Q has happened, because that's a premise we assume to be true, and we also know that Q has not happened, then P must have happened. So with disjunctive reasoning, if we give you a or statement and we say that one of them didn't happen, then the other one for sure did. The misuse of disjunctive reasoning is if we say P or Q, and then we know that P, so if we say P or Q has happened, and then we also know that P has happened, we can't assume that Q has not happened, because a P or Q statement can be true when both of these things are true, or both of them have happened. So even though we know P or Q has happened, that's true, and we also know P is true, we can't necessarily conclude that Q is false or that it didn't happen. Q could be true or false, so we can't necessarily conclude either one of these. So this is basically saying if P or Q happens and you know one of them has happened, then you can't necessarily conclude that the other one didn't happen, because under disjunctive reasoning, both of them could have happened. All right, so let's get into some examples here, and I'll point back at this table. The point of what I'm going to do here for the examples is I'm going to translate these examples into symbolic form, and if the symbolic form fits one of my valid argument forms, then I'll say it's valid, and if it doesn't, then I'll say it's invalid. So the first thing we do when we do these problems is we take the first premise, which is the first sentence, and we define what our P and our Q will be. So if we define, usually it's just very simple, just define the first part of the compound statement to be P. So that's going to be P, we don't get gas. P is we don't get gas. And Q is going to be won't make our destination. All right, so that's what P and Q are. All right, okay, so that's just defining what P and Q are. I haven't even started translating this symbolically. So the first premise, this is an if-then statement. This is an if P, then Q. So P, if P, then Q. All right, that's premise number one. Then our second premise is we made our destination. So that one, so notice I called Q not making our destination. So my second premise is that it would be not Q, because made our destination is the opposite of not making our destination. And then the conclusion here, which follows after the symbol here, the three dot symbol, which means therefore in logic, says we got gas. Well, if P is we don't get gas, then this would be not P. All right, so what we have here is we have a premise that says if P then Q. We have not Q as the second premise. Can we necessarily conclude that not P happened? Well, this is exactly contrapositive reasoning. If you know that if you have if P then Q, but Q has not happened, then you can guarantee that P has not happened. So that is valid. It fits that valid contrapositive reasoning. Okay, next one. This semester you take physics or chemistry. So I'm going to say P is the statement physics, taking physics. I'll just say take physics, and Q is a statement take chemistry. All right, so then my first premise is P or Q. This semester you take physics or chemistry, so that's the or, that's our disjunctive reasoning, our disjunctive symbol, the V. So that's our first premise. Then the second premise is the next statement, premise, I took chemistry, so that's just Q. And then the conclusion is I don't take physics, so P is take physics, so this would be not P. So this fits into the invalid form of the misuse of disjunctive reasoning. This is basically saying this semester you take physics or chemistry. I took chemistry, so therefore can we necessarily conclude that you didn't take physics? Physics, absolutely not, because you could have taken both. So this is invalid. So you know this semester you take physics or chemistry, which means you could take physics alone or chemistry alone or both. And we also know that we took chemistry. That doesn't mean that we don't know, or that doesn't mean that we know for sure that we didn't take physics, because we could have taken both. So it's invalid. All right. So let's look at another similar one here. We'll just do the same statements here. P is take physics, and Q is take chemistry. Okay, and then our first premise is the same thing as above, P or Q. And then a second premise is didn't take chemistry, so that'd be not Q. And then the conclusion is I didn't take physics. So this doesn't fit in the table, but this is invalid as well, because if you say I took this semester you take physics or chemistry, and you also know that you didn't take chemistry, the only thing that we can necessarily conclude is that you did take physics, but this says you didn't take physics. So we know that's wrong, that's invalid. We definitely cannot make this conclusion based on these premise. The only conclusion that we can make is that you did take physics. So that's invalid. All right, we're going to do this again. So let me just copy and paste the first line here, or two lines, excuse me. Take physics, take chem. This semester you take physics or chemistry. And then the second premise is I didn't take chemistry, so that is not Q. And then the conclusion would be that I took physics, which is P. That is definitely valid. That is exactly the disjunctive reasoning that fits right here. If we say P or Q and one of them didn't happen, then you can conclude that the other did happen. So that's valid. All right, let's do the rest of these examples. So actually, let me do the rest of these in part 2.